Lesson 11.10, using mean value theorem to find C. So no new theorems. This is using MVT to find an X value. We are going to be given some kind of polynomial, and we have a graph, so that's good. It says plot a line segment connecting the points on F where x equals -5 and x equals 0. Afterwards, determine all values of C which satisfy the conclusion of the mean value theorem for F on the closed interval. So because polynomials are always continuous and differentiable, we don't have to worry about any of that. It meets our criteria for MVT. So that does guarantee some value of C, at least one, sometimes more than one, that satisfies this conclusion. So first, let's put a point where x is -5 here, and where x is 0 here. I want to draw a line as straight as I can. I better get a ruler. And then that would be the average rate of change. And so there's got to be some other x value where it has that exact same slope. And you can kind of tell, but let's try to figure it out mathematically. So what I would want to do, since I have a graph, is I have ordered pairs at -5, that would be counting by 10, and 0, -10. I want to figure out what is the average rate of change. What's the slope there? So I'm going to use AROC to abbreviate. Remember, it's y2 minus y1 over x2 minus x1. So it'd be 0 minus -5, be -20 divided by 5, which is a slope of -4. That's what this line is decreasing at, is -4 over 1. I need to then find the slope function. That means take the derivative. Gets 3x squared plus 4x minus 19. And then say my slope of this function needs to be -4. So it's just like when you find critical values, but this time we want it to be specifically a numerical slope. So I would have to add my 4 over, get it set equal to 0. Doesn't look like I can factor anything out, so I'm going to have to slide and divide. Be +9 and -5. Divide by 3. So that's really x plus 3, which would get me an answer of -3. And then that would be x minus 5/3, so my answer would be x equals +5/3. Okay, so looking at your domain, we have to stay between x values of -5 and 0. So this one works, but 5/3 is too big, so that one's out. And if you look here, I could already kind of tell that at x is -3, it looks like it would have the same rate of change. So pretty cool. All right, and number 2. We've got a new function. Wants us to plot a line segment where x is -1. So we got a point at -120. And then it's 720. What do you notice? I noticed that that slope is 0 because I have a 0 change in y over whatever, 7 plus 1, 8, slope is 0. So really I'm just setting this derivative equal to 0 and trying to find a max here and a min here, which it looks like I know it, but just in case I better set it equal to 0. So that would be my 3x squared minus 20x plus 17. Slide that over. 51, I think. And then that would be 3 and 17 again, both negative. Divide by 3. So that would be x minus 1. That would get me an answer positive 1. And then that would get me a positive 17 thirds, which is almost 18 thirds. That's almost 6. So yeah, that's like right here at 17 thirds. And then that was here at 1. Should probably put x equals, but anyway, so you get 2 answers that have the same slope. And that's it.